Good evening, sir.
Good evening, Jitendra. Just 1 minute. We'll be starting with everything.
Good
Okay.
evening, sir.
Good evening, Yukta.
Sir,
Just 1 minute. I'm starting. I'm just opening up the assignment which we'll be solving today.
okay, sir. So today we'll do physics.
Yes, today we'll be doing physics.
Okay, sir.
So just give me about just 1 minute more, I think. With that, we'll be able to solve a few assignments, and after those assignments, we can finish off this chapter. Actually, even the chapter is finished. We are just going to practice question answer from this, so we'll finally have finished this chapter.
Okay, sir.
Okay, and I can take up if any doubts you people have. Like some of you may have doubts from your book, from your school, from your exam. Okay, if anything of that sort you are having, so you can ask that also.
Okay, sir. Okay, sir. Yeah.
Yes, yes. What happened? Okay, we had solved the NCRT question answers from this topic, right?
Yes, sir.
Okay, all of you be ready with your copy and pen. You must have your copy and pen with you. Okay, so actually I had a Kendriya Vidyalaya material which had all question papers from all the chapters. So this assignment currently which we are doing, it includes the assignment from all the topics that we have done. That means including motion as well as the force and laws of motion.
Sir, can you send this in the group?
Okay, I will try to send it through the group also. See, eventually what happens, I have just continuous classes. So it's certainly I forget something that what I was about to say.
So you
So
can
that's why
send it
most of the time I'm not.
manually. If you upload, it will be sent after a few minutes because it's 154 pages, right? So
Okay. So I'll try to send it over there only. Okay, so shall we start with questions of motion? Let's see, we have some questions of motion. Okay, so let's start with this graph first. Calculate the speed from the given distance time graph. Okay, so who will
sir,
tell the answer?
sir, distance is in kilometers or meters?
Okay, distance is if it's not given, we assume it in meter per meter. Let's say distance is given in meter and time in second. The time is already marked here as second, 0 to 2
So 2
seconds, 3 to
meter
6
per
seconds.
second.
Yeah,
Sir, uniform motion with 2 meter per second.
okay, it's 2 meter per second. And if you are asked like this during 0 to 2 second, so if you find between 0 to 2 second, again your answer will be the same, 2 meter per second. Okay, here calculate the retardation between 0 to 4 seconds in the given speed time graph. So from the speed time graph or velocity time graph, the retardation can be calculated as change of velocity by time. So what is the value of retardation here?
It's a 5 by 2 meter per second square. Minus 5 by 2 meter per second square.
See, acceleration is minus 5 by 2, but retardation is plus 5 by 2.
Okay, sir.
Okay.
Sir, if they give retardation, we have to change the negative into positive, or if it is positive, shall we change it into negative?
No, for the retardation is negative acceleration.
Yes, sir.
Okay.
Okay.
So if you get negative acceleration, it is retardation.
Sir, negative retardation means positive acceleration,
No.
right?
Yes, yes, yes. But it's generally we don't use negative retardation.
Okay, sir.
So calculate the acceleration in distance traveled between 0 to 4 seconds. So all of you try to do this question. You have to calculate the acceleration and distance traveled between 0 to 4 seconds. Okay, try out. All of you try out. And those who are not getting, like see someone is speaking and getting the answer. So those who are not getting, you should be asking, sir, I didn't get it. Then only I will explain that how the answers are obtained. Otherwise, it seems that you are getting. Okay. So all those who are not getting, please inform.
Sir, is it 2 meter per second square?
Okay. Is there anyone else also who has got? Anyone else who has got the value of acceleration here? Okay. Is there anyone who is not getting how to find out the value of acceleration during this time? Advait?
You can tell me how to do it.
Because,
Yeah,
sir,
Advait, what is the answer? Yes.
sir,
Yes.
so is it 2 meter per second square?
Yeah, it is 2 meter per second square. And I want everyone to participate. Rohit is there? Is there Rohit? No.
No, sir.
Okay.
Is
See,
that
acceleration is found as we find acceleration by the formula. Okay. See, here if I want to find out acceleration, so acceleration is given as change of velocity by time, v minus u by t. So there are different ways by which you can look off, or it is also given as slope of the graph. Okay. So you have to find between 0 to 4 seconds. So if I observe the graph between 0 to 4 seconds, so at 0, when the time is 0, its velocity is also 0. So you can see initial velocity is 0. The final velocity, that is at time t equals to 4 seconds, the velocity is 8 meter per second. So final velocity is 8 meter per second and time t is given as 4 seconds. So we obtain acceleration as v minus u by t. Our final velocity v is 8 minus initial velocity 0 divided by time, which is 4. So it is 8 by 4 and this is equal to 2 meter per second square. Got it?
Sir, can you explain the same by slope method?
Yes.
Sir, can you explain this in the slope method also?
Yeah. So if you want to try it by the slope method, so observe the graph between 0 to 4 seconds. It's a straight line. Okay. And during this time, the length of the perpendicular divided by the base. Okay. So you can see the slope is given. The formula for slope is rise by run or height by base. So rise by run, the graph has a rise of 8 units. So rise is 8 divided by run between this time. So run is 4. So 8 over 4, that is 2 meter per second square. Got it? Okay. Then we have to find out the distance traveled. So how do we find out the distance traveled from the velocity time graph or the speed time graph?
Sir, area under the graph.
Area under the graph. Very good. So find the area under the graph and it should be equal, it will be equal to the distance. Okay. So what is the area here?
Sir, L into B.
Not L into B. Area under the graph. So this is graph. Your AO. This is your graph.
Half into
Okay.
base.
Yeah, it's half into base into height. Okay. So area under the graph, it is a triangle. So area will be 1 by 2 multiply base, which is 4, multiply by height, which is 8.
Sir,
So
16.
it's how much?
Sir,
16.
16.
Yeah, so this area is 16 meter. So not area is 16 meter, area is numerically 16 and the value is of 16 meter, which is the displacement. So displacement we are getting here as 16 meter. Got it? Okay, try this one also. Another question here. Calculate the acceleration during AB and the displacement between 1 to 6 seconds from the given velocity time graph. So you are given here a velocity time graph now. You need to calculate the acceleration during AB and the displacement between 1 to 6 seconds. Okay, so has anyone got the value of acceleration between 1 to 4, between the region AB? Is there anyone who has got this value?
Sir, 1 minute. So 6.66 meter per second square.
See, just during this region, during the region AB, if I use the formula of slope, so my slope is given as perpendicular or rise by run. So rise is 20. It's 20 divided by run. Run is from 1 to 4, that is 3. Okay, it's 4 minus 1, that is 3. 20 by 3, that is 6.6
6.66.
meter per second. Yeah?
Yes, sir. 6.6 bar. So we can
Yeah.
also 6.66 also.
Okay, okay. So, but we don't need that much of accuracy, right?
Okay, sir.
Okay. So this is 6.6 meter per second square. Okay, anyone having problem in finding out the acceleration? Now, how we will find out the displacement? How do we get the displacement during this time?
So we have the acceleration. Also, we have the initial and final velocity. So we can use the second law of motion, second equation of motion. S is equals to ut plus 1 by 2 at square.
See, I want the complete displacement. Okay? Displacement between 1 to 6 seconds. So for starting from here, I want up to 6. So as I know that area under the graph will be equal to the displacement. Okay. So here area will be equal to displacement. And hence I can divide this area as, if I observe this area, so this is
So
a
that
part
will
is
be
a triangle and a part is a rectangle. So either you use the formula of area of
so
trapezium. Yes.
yes, sir.
Either use the formula of area of trapezium, or you first find the area of triangle, then the area of rectangle. Okay, so if I use the area of trapezium, it will be equal to 1 by 2 multiply sum of parallel sides, multiply height. Okay. So it is 1 by 2 multiplied with the sum of parallel sides. The parallel sides are
6.
BC and the 6 AN. So BC is 2. You have 2 plus 6 multiply by height. So height is 20. Okay. So you
Sir,
get your answer here. 10 multiplied with 8, which is 80 meters. Everyone got the answer?
Yes, sir.
Okay, see, for the next question, in the given figure, find the speed between 10:30 a.m. and 11 a.m. This one. And whoever shows me the solution, accordingly, I will report your feedback. Like, I can report your feedback that how you are performing during the classes. So your performance will be rated according to these questions which are solved. If you don't solve, if you don't give any responses, so obviously you will not get any feedback, or you will get a negative feedback.
Sir, what is the timing? Sir, of the question.
The timing for this is just 3 minutes.
Sir, sir, can you read the question
Yes,
once?
sir.
Okay, you have to find the, okay, I'm just giving you the question here. Maybe the question has not come. The question is this. This is the question. You have to find in the given figure, find the speed between 10:30 and 11 a.m.
Sir, it's moving at uniform speed.
Okay, it's moving at a uniform speed. So what is that speed?
20 kilometer per seconds.
Say just one person is answering. Okay, don't answer like this. Solve the question, and I want to see everyone's answer. Accordingly, I will give you the feedback.
So can we write it in kilometer per hour, or shall we send it in meter per second?
Write it in kilometer per hour only. Okay. Those who do not respond, I will be providing them a negative feedback then. Your answer should be there. You should be ready with your answers. I'll be asking the answer from any one of you.
Sir, I have to show you the answer now.
Yeah.
Sir, should we show the answer or keep the pic in the chat?
You just send your answer in the chat as a personal message.
Sir, can you show next question
Just okay. I think 4 people have answered, and time is about to over. Just about 30 seconds are remaining. What about the rest of them? Rest of you? Okay, is there anyone who is not able to get this question?
Sir, I couldn't understand.
Okay, Sharwan, what do we need to find in this question?
So we need to find the speed.
Okay, we need to find speed. And what graph is given to us?
Distance, time graph.
Okay, distance time graph. So how do we obtain speed from a distance time graph?
Distance by time.
Distance by time. Very good. And what is the duration that is given to you?
15 minutes.
Uh, in which duration? I have to find it between 10:30 a.m. and 11 a.m.
Yes, sir.
Okay.
For 30
So
minutes.
at 10:30 a.m., if you look up at the graph, so at 10:30 a.m., where is the how much distance is traveled?
20.
20 kilometer. Very good. So at 10:30 a.m., the distance traveled is 20 kilometer. And what is the distance traveled at 11 a.m.?
30.
Okay. At it,
Mm,
just check how much at 11 a.m.
Sir, 40.
40. Okay. So at 11 a.m. it is 40 kilometer. Now what is the distance traveled during this time?
So what?
What is the distance traveled during this time? 10:30 to 11 a.m.
13 kilometer.
13 or 20. See, at 10:30 it had traveled 20 kilometer. At 11 a.m. it has traveled a distance of 40 kilometer. So what is the total distance traveled during this time? How much distance has it
60.
traveled during how much?
6
During this time?
time.
Between 10:30 to 11 a.m. what is the distance traveled?
60 kilometer.
Not 60. See, at 10:30 it had traveled 20 kilometers. So assume it like this. See it like this. So it started from a certain point. At 10:30 it was here. It had traveled a distance of 20 kilometers, right? Then after some time, it has at 11 a.m. Now it has traveled a total distance of 40 kilometers. So this is the total distance traveled 40 kilometer, and this is the distance traveled 20 kilometer between these two. So what is the distance traveled between these two time intervals? 10:30 and 11 a.m. What is the
10.
distance traveled during this time interval?
30.
30 or 20? See, 40
Sir,
kilometer
20.
is 20, right?
20.
So
20.
20 kilometer. And how much
Yeah.
time it has taken?
15.
15 or 30 minutes. See, the time taken is 30 minutes. We are counting from 10:30 to 11 a.m. So from 10:30 to
Okay.
11 a.m. it is 30 minutes.
Yes, sir.
Okay. So here the time is 30 minutes. And if I convert this to hour, I will get 1 by 2 hour, right?
Yes.
Okay. So I think I see many people have answered now. So now I can get the speed. Speed will be equal to total distance by total time. The total distance traveled during this time is 20 divided by time, which is 1 by 2. So if I transpose this 2, it becomes 20 multiplied 2, which is 40 kilometer per hour. Okay. So let's see how many of you got. Okay, only one person. Likita, I think, has sent 40 kilometer per hour.
So first, I thought it was 20, sir. Then it was 40.
Okay, just 1 minute. Then, okay, this is again 40 kilometer per hour. Who is she? 40 kilometer per hour Likita, and Yukta also 40 kilometer per hour got. Okay, Sampath got 40 kilometer per hour. Yukta got 6.6 meter per second. Harshit got 20. So Harshit, your answer is incorrect, right? Harshit, Jitendra.
Yes, sir.
Okay. Advait, if you are not able to unmute yourself, you can try to rejoin the class. Okay, or let me try if I can make you unmute. Advait, do you see an option to unmute yourself? Try to unmute if you are able to get it. So everyone has got now, the speed is 40 kilometer per hour. We'll see the next question here. So this one is a velocity time graph. And in the given velocity time graph, interpret the nature of object's motion and calculate the acceleration and displacement between time interval 2 to 4 seconds. So again, I'm giving you for this question, I'm giving you a time interval of 4 minutes. Okay. So as soon as you start getting your answer, you start messaging for this. Also for this question, the first part you may leave, like in the given velocity time graph, interpret the nature of the object motion. So this you can leave and you can continue with the next one. Okay, so is there anyone who has got the answer?
Sir, I have got the acceleration.
Okay, so okay, I think Yukta has got. So all those who have got acceleration, just start messaging over here in the personal chat. You can message for acceleration, and then you have to find the displacement also. Now only 2 minutes remaining. Okay, anyone got the answer? Few, I saw few people are leaving, so don't leave. Just okay. I'm giving you the answers now. I think that many of you are not able to get it.
Sir,
Okay,
can
so
you
see,
sir, one more
yes.
minute.
Okay. Okay, I'm writing the formula for acceleration and try it out then. Those who need help. So acceleration is given as slope of the graph, and this is given by rise by run. Okay. Or you can also find by other methods. If you know I, you can also use A equals to V minus U by T. So whichever one you find suitable. Then the displacement S will be given as area under the graph. The displacement is given as area under graph. Okay, so now the time is over. I think everyone has done. I just got 2 responses. So see,
Sir, 1 minute, sir. I'm posting it.
okay. Okay, let's see. Acceleration now is given by the formula slope, which is you just have to find out between the region 2 to 4 seconds. So since the graph is a straight line, whatever region you choose, you will be getting your correct answer. Your answer will be the same. But since the question says for the region 2 to 4 seconds, we use this region only. And during this region, we obtain rise by run. The rise in the graph during this region is 16 minus 8. So for this one, this position belongs to 8 and this position belongs 16. So you have this rise given by 8. The run is given as 4 minus 2. So acceleration is 16 minus 8, that 8 divided by 2, which is 4 meter per second square. The displacement during this region will be given as area under the graph. So during this time, the area under the graph is a trapezium. See, this is a trapezium now. Maybe some of you might have taken it as a triangle. So the area under the graph, it becomes a trapezium like this. So for this trapezium, I know that displacement or will be equal to area, which will be equal to 1 by 2 multiply sum of parallel sides. So here the parallel sides are these two vertical sides, that is 8 and 16. So you have 8 plus 16 multiplied by time, that is the height, which is 2. So you get 2 and 2 cancel, 16 plus 8, that is 24 meter is the displacement during this time. Okay, now let me check who all have got this as correct answers. Okay, Likitha got correct, Jitender got correct.
Sir, I didn't get the
Which one?
sir displacement. I'm getting confused.
Displacement is area under the graph. See, you observe the graph and from the graph drop perpendiculars on the x-axis. Okay, Sampath has also given, Harshit, Jitendra. Okay. Okay, acceleration I think almost everyone has got. Okay. So see, here the region given was 2 to 4. So from 2 to 4, you choose your graph. I initially choose the graph over here. So this is my graph. Okay. The area under the graph will be a trapezium. See, this is our trapezium now. Okay. We got the trapezium here. Got it? So do not assume only this triangle portion. The complete area under the graph, that means area under the graph and x-axis. Okay, so that is the complete area. I have to evaluate this area, which will be equal to the displacement. Okay, try one more question. Now I'll be reducing the time given. Okay, see this graph. Question 3. Okay, the first question we'll discuss later. We'll try this part B first. Calculate the acceleration and displacement between 5 to 10 seconds. Okay, so try doing it. Now time for calculating the acceleration is just 1 minute. And time for displacement is also 1 minute. So you have now time of only 2 minutes to solve it out. Okay, so let's solve it out. The time is over. Let's see. A few people have got the answers. So here acceleration is rise by run. I have to look for the graph for the region 5 to 10 seconds. So I select the graph during this region 5 to 10 seconds. This is the region of the graph. So during this region, the slope will be given as rise by run. Since it's not rise, it's fall. So we'll be taking this as negative 25 divided by 5. This is negative 5 meter per second square. And your displacement S is given by area of this, which is just a triangle. Area under the graph and the x-axis is now just a triangle here. So this area between 5 to 10 seconds will be 1 by 2 multiply base 5 multiply height, which is 25. So it's 75 by 2, which is 37.5 meter per meter. Okay. Now let's see how many people have answered this correctly. Okay, Likita got acceleration correct. Yukta got acceleration incorrect. Okay, Jitendra got acceleration correct. And during this time, only 3 people were able to answer.
Sir,
Yes, yes.
so could you once show how to find the acceleration in another method like initial velocity minus final velocity minus initial velocity by time?
Okay. From the graph, see, learn to read the graph. So
Sir,
you have to find the acceleration between the region 5 and 10 seconds. Okay. So from the graph, look for 5 seconds, and at that time draw a perpendicular. So at 5 seconds, you need to draw a perpendicular and see where it cuts the graph. Okay. Also draw a perpendicular at 10. So at 5 seconds, where it cuts the graph, from that point, look up for the y-axis. The value of the y-axis is 25 for this case. Got it?
sir,
Yes.
5 into 25.
What happened?
5 into 25 is 125, sir.
Yeah, 5 into, okay, it's 125. Sorry. Sorry. My bad. It's 125. You have 125 divided by 2. That makes it 62.5. Okay, now it's correct.
Yes, sir.
Okay. Okay, so for this time, your displacement is given as, okay, initial velocity. That means at the time t equals to 5 seconds, we observe that the velocity is 25 meter per second. Then at final time at t, yes. So this one, final at time t equals to 10 seconds. I observe that it cuts the graph here only, and from here if I drop a perpendicular, I'll get 0. So from the graph, I can read initial velocity to be 25 meter per second and final velocity v as 0. The time for this is 10 minus 5, which is 5 seconds. Now I can use the formula of acceleration as v minus u by t. So v is 0 minus 25 divided by 5. So 0 minus 25 is minus 25 over 5, which is minus 5 meter per second.
Okay, sir, got it.
Okay.
Sir, can you give a next question?
Yeah, just. The next one. A passenger lift starts from rest, accelerate uniformly, and attains a speed of 4.6 meter per second in 2 seconds. This speed is maintained for next 6 seconds. Then the lift undergoes uniform deceleration and stops in the next 2 seconds. Draw the velocity time graph for the lift and calculate the distance covered by the lift in 10 seconds. So let's try to draw the velocity time graph for the from the given information. Okay, see, a passenger lift it starts from rest. So I've chosen my graph, and here let us construct the coordinate axis first. So here on the vertical line, I'm taking this one as 0, 1, okay, 2, 3, 4, 5, 6, 7, 8, like this. And okay, it's talking about just 4.6. And here I'm taking time as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So a passenger lift, it starts from rest. So starts from rest means when time is 0, its initial velocity is 0. Then we obtain the next point. It attains a speed of 4.6 meter per second in 2 seconds. So when time is 2, its velocity is 4.6. So I'm taking it approximately between 4 and 5. So this is the point which we are looking for. This point is 4.6. So I'm also marking it here. This point comes out to be 4.6 meter per second. Okay, when the time is 2, its velocity is 4.6 meter per second. Then this speed is maintained for next 6 seconds. So after this, for the next 6 seconds, the object undergoes in the same way. So if I draw a graph for this, at the beginning it was 0, then it reached 4.6. Then it continues with the same speed 4.6 for the next 6 seconds. So if you consider the next 6 seconds, it will reach 8 seconds. Since we had already started with this 2 seconds were already over, so it continues with the same speed and reaches the graph at 8 seconds. Then the lift undergoes uniform deceleration and stops in the next 2 seconds. So in next 2 seconds, okay, so this is your 8 seconds. Now the lift decelerate and it stops. So finally it stops. That means its velocity becomes 0 in the next 2 seconds. So the graph is something like this. Okay, everyone has understood how did I plot the graph? See, if you are there in the class, if you are not getting, okay, just wait a minute, someone is, yeah, is there anyone who is facing any issue?
So can you explain one more time?
See, a passenger lift starts from rest. It starts from rest. That means the initial velocity is 0. So we take the initial coordinate to be 0, 0. When the time is 0, the velocity is also 0. This is the initial coordinate. Then after 2 seconds, see, accelerate uniformly and attain a speed of 4.6 meter per second in 2 seconds. So in next 2 seconds, it attains a velocity of 4.6. So I obtain the coordinate 2, 4.6 on the graph and join it with this original line, with the starting line. Then the second one, this speed is maintained for the next 6 seconds. So for the next 6 seconds, it continues with the same speed. So the line is a horizontal line, which represents that the speed is constant during this. Then after that, the lift undergoes uniform deceleration and stops in the next 2 seconds. So in the next 2 seconds, the lift is stopped. So after it's 2 seconds, that is 10 seconds. And final velocity also becomes 0. Draw the velocity time graph of the lift and calculate the total distance covered by the lift. So I have already drawn the velocity time graph over here. So here, now I need to find out the distance traveled. So I will be finding the area under the graph. Okay. So for the area under the graph, this is our triangle. This is a rectangle, and again we have triangle. So for the triangle, we have 1 by 2 multiply
Sir,
2
can we
multiply
take it as
height.
trapezium? Sir, it would be easy if we take it as trapezium.
See, if you take a trapezium, so this, okay, you can also take it as a trapezium with, you can take either individual one or you can take trapezium. So if I use the trapezium method, so it will be 1 by 2 multiply sum of parallel sides. Your parallel sides are 10 and 6. So 1 by 2 sum of parallel sides. So your parallel side are this one and this one. So parallel sides are 10 plus 6 multiplied with height, and height is 4.6. You write 4.6 here. So 2, you cancel it, you get 2.3. So 16 multiplied 2.3 is the displacement. Got it? Anyone having any problem now?
No,
16
sir.
multiplied 2.3, that is 36.8. See, I see here that there are 5 people, and if you are not getting, and if you are also not able to inform me, so how will I know that where you are not getting? You need to inform me. If you can't inform here, just message me directly. If you can't message here also directly, message me on my WhatsApp. Okay? I'll try to provide a feedback. I will try to make you understand some way or the other. Got this answer? Let's see the next one. So for this one, we are doing complete question. Okay, see. Jitendra, have you understood?
Yes, sir.
Okay, Yukta,
Yes, sir.
Sarvan, what about you?
Yes, sir, I understood.
Okay. Okay, see. So for this question, interpret the nature of graph. So interpret the nature means you have to tell what type of motion is shown in this graph. So what type of motion is shown in this graph? Okay, see, if we observe the region O to B, that is during the first 2 seconds, the graph shows a uniform acceleration. It shows a uniform positive acceleration, and the object is changing its velocity at a constant. For the next 3 seconds, the object is having a uniform deceleration. Okay, so in the next 3 seconds, its velocity is decreasing. For the second part, which part of the graph represent uniform acceleration? So that is part OB will represent uniform acceleration. And which part of the graph represent uniform retardation?
Sir, BC.
BC, yes, BC part of the graph, it represents uniform retardation. Okay. Then some more questions from from the same graph. Okay, calculate acceleration and retardation. Also the total distance traveled. Find out this. Calculate acceleration and retardation. Also calculate the total distance traveled. Okay, so what is the acceleration?
There is the acceleration 2 meter per second.
Yeah, acceleration is 10 by 2, that's 5 meter per second. For this region, acceleration is positive acceleration is during the region OB. So during the region OB, the perpendicular or rise is 10 and divide by run, which is 2. So 10 by 2, that is 5 meter per second. Okay, for the next 3 seconds, there is retardation. So if you find a retardation would be equal to negative acceleration. Now, again, you have the fall of 10 and divide by 3. So that is 3.3 meter per second square. Okay. Okay, find out the okay, find out the distance traveled. Okay, see, I'm telling you the answer since the time is okay. Distance is 25. Okay, Jitendra has answered 25. Let's see. So displacement will be again area under the graph, or distance will be the area under the graph. So 1 by 2 multiply base, that is 5, multiply height, which is 10. So it's 25. 25 meters. Okay, I feel that some of you are not getting the concept. So I'll be sharing these questions so that you can practice over there. Okay, bye all of you. See you again.
Thank you, sir. Bye.
Okay, bye.
Thank you so much.